Assalamualaikum and hi everyone, welcome to our MAT 183 video presentation. Before we start, let's get to know our group members.
Hi everyone, now let me continue our presentation today. Start with introduction. What is differentiation? Differentiation is process of finding the derivative or rate of change of a function. It is the significant concept apart from the integration. This is because both of the concepts help solve many types of real problems. Differentiation can be used to measure the function per unit change in the independent variable. These are some examples that we can try to differentiate. The first example is y equal to x to the power of 4. When we differentiate, it will be dy over dx equal to 4x to the power of 3. Next, y equal to 2x to the power of 4. When we differentiate, it will be dy over dx equal to 8x to the power of 3. And last but not least, y equal to x to the power of 5 plus 2x to the power of negative 3. When we differentiate, it will be dy over dx equal to 5x to the power of 4 minus 6x to the power of negative 4. Next, when do we apply differentiation? Differentiation was applied when determining the increasing or decreasing of a function. It is also used to determining the speed or distance of moving object. Other than that, based on our topic, the derivative was used to find the maximum and minimum value of a particular function. There are 5 applications that we can use in differentiation. The first is related rates, analysis of function 1, analysis of function 2, applied maximum and minimum problem, and lastly, role theorems and mean value theorem. But in this presentation, we would like to focus in one application that is applied maximum and minimum problems. What is applied maximum and minimum problems? It is the process of finding maximum or minimum values that is called optimization. For example, we will maximize the profit in a company or minimize the cost and to find the least amount of materials to make a particular project or object. But then how we can know how to solve it? Okay, I will tell you 3 steps on how to solve maximum and minimum problem. Firstly, we need to find the derivative. Next, let the derivative equal to 0 and find the values of the variables. The last step is we need to do the second derivative test. If the second derivative less than 0, it is a minimum value. If the derivative greater than 0, it is a maximum value.
Problem statement. Our problem statement is a closed rectangle box with square base is to hold 260 cm³ of water. The material for the side and for the top cost Rm 1 ringgit 50 cent per square cm and Rm 2 ringgit 50 cent per square cm respectively. Let X denotes the side of the base and Y the height of the box as shown above. A. Show that the cost C of the material is C equal to 5x square plus 1296 over X. B. Find the value of X and Y that will minimize the cost of the material. C. Hence, find the minimum cost of the box.
Okay, for the problem solution, based on the question A, we can conclude that we need to show that the cost C of the material is C equal to 5x square plus 1296 over X. So, based on the diagram, we can see that it is a rectangular box. So, for the volume of rectangle is length times with width times with height. So, we will get x square y. So, the given one is 216 centimeter square. So, x square y equal to 216 and y as a subject is y equal to 216 over x square. Okay, for the cost for the side which has 4 sides is 1 ringgit and 50 cent per centimeter square, and cost material for the top and base is 2 ringgit and 50 cent per centimeter square. Okay, for the total cost, we can calculate that it is 2x squared times with 2.5 plus 4xy times with 1.5. we will get 5x square plus 6xy. If y equal to 216 over x square, and then cos we will get 5x square plus 6x bracket 216 over x square, and then the answer will be 5x square plus 1296 over x, and it is shown. Okay, for the question B, we need to find the value of x and y that will minimize the cost of the material. So for the step 1, we need to find the derivative. So from the cost, which is 5x square plus 1296 over x, we can differentiate it and it will become 10x minus 1296 over x square. For the step 2, we need to let the differentiate equal to 0. So the differentiate is 10x minus 1296 over x square equal to 0, and then we will get x equal to 5.0606. Okay, for the step 3, we need to find the second derivative test. So based on the first derivative, we can get the second derivative, and the answer will be 10 plus 2592 over x power of 3. And then when x equal to 5.0606, we can get for the second derivative is 30, and then the 30 is larger than 0. If the second derivative is larger than 0, we can conclude that it is a minimum value. So x is a minimum value. Okay, when x is 5.0606, we can get y value, which is we substitute x from the equation before, which is 216 over x square. So we will get y equal to 8.4343. Okay, for the question 3, the question asks that we need to find the minimum cost of the box. So from the value of x given, from the value of x we get, we can substitute it on the equation for the cost. So equation for the cost is cost equal to 5x square plus 1296 over x. So we substitute x with 5.0606, and the answer we will get is 381.14, and the last answer will be 381 ringgit and 14 cents.
Before we wrap up, I would like to conclude that the first derivative test or the second derivative test can be used to resolve optimization problems. The first derivative approach is applied to determine the maximum profit gain. The optimization process, it is commonly used in our daily lives. This apply maximum and minimum problems benefits people in understanding and calculating business profit and loss as well as cost. However, to construct a function, we must fully analyze and understand the question. From the problem statement in this project, firstly, we should determine the cost of the material to make a closed rectangular box to hold the water. Next, find the derivative and let dc over dx equal to 0. X value is determined, which is 5.0606. Furthermore, second derivative test is used to determine whether it achieves maximum or minimum value. In this case, minimum value is achieved. Lastly, the objective to find the minimum cost is obtained. That's the end of our presentation. Thank you and bye!